Hello, my name is Noah Smith and I work at Arkansas State University in Dr. Hershberger's lab. Today I am here to talk about a novel method to potentially develop medically useful compounds. It is simple, easy, efficient, and uses well-established reactions in a new way. The method creates chemicals that contain the 2-amino pyrimidine group, a functional group present in several antifungal, antibacterial, and anti-cancer drugs. Meaning it is useful to create new 2-amino pyrimidine containing chemicals as they have a chance of being medically viable. First, I want to talk about the reaction series devised for this purpose. This can be seen in the section labeled Methods at the bottom left of the poster. This reaction series is 3 steps: a Bigonelli reaction, an oxidation, and Ugi-Smiles reaction. These reactions are well studied, easy, and efficient. The novel portion of this design is that they are performed in series and that a Bigonelli product has not been used in an Ugi-Smiles reaction before. The results of this method can be seen in the Results section in the middle of the poster. The columns of this table are, from left to right, the reaction ID, the amine used in the Ugi-Smiles reaction, the aldehyde used in the Ugi-Smiles reaction, the physical structure of the specific product, and the yield of the reaction. As can be seen in the yield column, the yields vary from 20% to 70%, so the reaction series can be said to have a moderate yield. Next is a section labeled Purification at the top right. This concept is important as it removes any unwanted products from the desired products. This allows structural conformation by NMR and IR. It works by passing a mobile phase of a certain polarity in the crude product through the stationary phase of a different polarity. This causes all the chemicals present in the crude product to separate based on their polarities, as the individual compounds will stick to the stationary phase at different rates, making it possible to remove all unwanted chemical products. Again, this is very useful in all areas of chemistry and pharmaceuticals to prevent unwanted effects and reactions. The pure produced chemicals' biological effects are listed in the section directly below the previous. They were tested by the use of a disk diffusion assay, which tests the size of inhibition zones created by the experimental products versus a known antibiotic. Several different bacteria were tested against, including both gram-positive and gram-negative bacteria. The results, as listed, were that all products failed to produce an inhibition zone, meaning they failed to produce any inhibitory effects on the tested bacteria. So, all in all, this experiment succeeded in producing the expected structures, had relatively good yields, but failed to produce any effects on the bacteria. This result is acceptable as the purpose of this experiment was to devise a method to produce various 2-amino pyrimidine containing chemicals, which it did. Just because the produced chemicals do not have any effects on the bacteria does not mean all the chemicals this method is able to produce are ineffective. In the future, more work will need to be done to further increase the yields of the reaction and test a wider range of bacteria, insects, and fungus. I would like to thank Dr. Alam for allowing the use of his equipment, the FRAC for funding, and Hansaraj and Grace Hawk for help performing the biological test. Thank you.